Alright, hello guys. We want to dive into Chapter 3, Topic 6, dealing with parallel and perpendicular lines. So we will start out first by talking about the parallel side of this. So if we have lines that are parallel, what do we know about them? Well, I have a drawing here of the best I can do with an XY axis, and two lines, blue and red line here, and if they are actually parallel, which they're pretty close for me drawing on here, then that means that they have exactly the same, that is right, the same slope. So what we know is if we want a line that passes through the -3, -1 point and is parallel to this graph, then this graph we could probably think of potentially as being the higher or lower graph, depending on where we find out this point to be. But considering it's -3, -1, I have my guesses. You can go ahead and make your own. If we're going to go through the point at -3, -1, think about where that would be. So -3, -1 would be out here somewhere. So this graph, however, goes through a y-intercept of 3. So it's probably, maybe the higher one. So we will write a new function in slope-intercept form using this x and this y from this point. So go ahead and try that on your own. I'll come back with a little bit of help. Pause and give it a shot. Alright, so I went ahead and set up my new equation with the same slope as the equation of the line that I'm trying to match, since we're parallel. And we don't know the y-intercept yet, but we can replace our x and our y's with the -3 and the -1 from the point that we're trying to intersect. So that's where the -1 and the -3 come from. And then we do the math. We get -1 equal to -6 plus b. And then we add 6 to both sides to carry out the cancellation that we need to do, so that we get b by itself. And that tells me that b is in fact a +5. So then we can rewrite the new equation to be y equals, with the same slope as my first line, and a new y-intercept of 5. So actually, our new line is the higher line than the original line. So this one here, the 2x plus 3, would probably be modeled by this blue line potentially. Alright, so if you worked through the Pearson module, you should remember that parallel lines have the same slope, and perpendicular lines will have inverse reciprocal slopes. So if we had the blue lines and the red lines over here on the graph, then we can look at these being inverses or perpendicular. The fact that this one would probably have an upward slope of maybe a half, maybe a little bit more, and this one coming down would have a negative slope because it's coming down, and it would be steeper. We can see that more dramatically. Let me draw another pair. Let's say this one maybe has a slope of like 1/8, and then if I draw perpendicular to that, that'd be like -8. So if we had a right angle there, which again, I'm drawing the best I can. So over here, before we can compare whether graphs are parallel or perpendicular, we have to have them in slope-intercept form or point slope form before we can decide, because we need to know exactly what the slope is. So go ahead and try to set that up if you can on your own. I'll be back in just a second with help. Pause and give it a shot. Alright, so to turn this into slope-intercept form, well, my first equation is already slope-intercept, so I'm going to take my second equation and just put it in slope-intercept just to make life easy. So I like leaving my y on the left-hand side. I just think it makes things easier to work with. So I leave that there, and I get rid of the 4x by subtracting 4x to both sides. I then have -3y is equal to -4x plus 9. So then, to get y by itself completely, I would divide by -3. And that then leaves me with just y on the left side being equal to a +4/3 now, x plus 9. So now my slope is 4/3, and my y-intercept is 9. So let's check, is that an opposite reciprocal? So it would have to be the opposite sign and the reciprocal. So they are reciprocals, but they are not the opposite signs. They are both a positive slope. So they are neither parallel or perpendicular. So this set then is neither. If you have not tried B, go ahead and try B on your own. So that one was neither. if we give b a shot, my second equation is already in slope-intercept, and this one is pretty close to slope-intercept. I'm actually going to go ahead and just leave that there, because all that needs to happen to get the y by itself is divide by 6. But what happens when we divide by 6, that actually, I need to go back up because I forgot a step. When I divided by the -3 over here, hopefully you thought to yourself, but wait, we have to divide by -3 across the whole thing. So this 9 was actually not a 9. That should have been 9 divided by -3, which is a -3. So we can go ahead and erase that whole thing and fix that with a -3. Now the y-intercept does not really come into play that much, so still these are neither parallel or perpendicular just by looking at their slopes. So if we come back down here into b, when we divide by 6 on both sides, we then will get y on our left side by itself, -1/6 x plus 1. And we're trying to test, is it parallel or perpendicular to this line? Well, this slope, if I can actually get the highlighter, this slope is a -1/6, and this slope is also a -1/6. So we know that these lines are in fact parallel. So go ahead and think about this situation. We have a line that's going to pass through the point 1, 8 and is going to be perpendicular to that line. So go ahead and try that on your own. You know what the slope should be since it's perpendicular, and then you want the new line to go through this point of 1, 8. If you haven't paused and try it, do it now. Alright, so let's talk this through. We know that we want this to be perpendicular to the slope of 2. So perpendicular to 2 would be the reciprocal, 1/2, and then the opposite, so it's -1/2. So then we look at plugging that in for an equation that we don't really know anything else about, but then we do know the point, 1, 8, so we go ahead and take 1, 8 and plug the x in and the y in. So then 8 is equal to -1/2 plus b. To get rid of the -1/2 or the -1/2, we add 1/2. So then we get b is equal to 8.5. So the new equation becomes y is equal to -1/2 x plus 8.5. That is all I really have for you on parallel and perpendicular lines. The best thing to do is try the practice, see where you get hung up on. With a little bit of practice, these are easy to master, but you gotta practice or else they're easy to slip up. So be careful that you use either the same exact slope or the opposite reciprocal. Let me know if you have any issues. Work through the Pearson modules, and I'll see you in class. Have a great day.